Hey everyone, today I want to talk about something that might be a little controversial, but it's that Claude Code isn't for coding, but it is amazing for building multi-agent systems with natural language. By this I mean generalized agent systems, not just one for coding. Sub-agents, which have just been added as a first-class priority for Claude Code and allows for multi-agent orchestration. Next then is the challenge with a lot of the multi-agent frameworks and building multi-agent systems and agentic systems in production in general is state management, where there's a lot of infrastructure you have to set up and there is time overhead that you have to do to get the most value out of these agentic systems. The next is something I've been messing around with, which is what I call soft states, which are natural language based states that we then have these agents talk to each other through, that then allow for when you're setting up initial systems to be able to build them out very quickly and extract a lot of value without having to, one, know how to code or how to set up a lot of the heavy-duty infrastructure for production-type agent. I'm Ford Lascari. I am a applied AI engineer and consultant. I've been doing Gen AI for about 3 years full-time now and have been building agentic systems for around 2 years. And what I'm really trying to show here is, one, I've had a lot of failures building AI systems, and I want to show how to provide real value through them so that we can take this amazing technology and bring it to everyone. I just want to talk about the idea of how Claude Code could spawn itself. And this is nothing new with Claude Code, but they have just introduced the distinct sub-agents that then you are able to do this in a much more structured way than previously just saying spawn sub-agents, and it would go in a it would get it done, but you didn't have very much control over how it would do it. The idea here is that you can set up a parent agent that can orchestrate and delegate to various sub-agents. This could be research, coding, whatever it may be. You can say whatever these sub-agents are, the parent agent will spawn them. These agents will then go out and complete tasks and come back, and then the parent agent will aggregate the results. And what we see here is that then you are able to create these multi-agent workflows without any infrastructure code. And this is nothing new, but Claude Code has now made this a very first-class primitive within itself, where you are able to clearly define these agents, what tools they have access to, and what they should do, and then connect them all together. What you'll notice, though, is when you're starting to build with agentic systems is when you first start out, you'll see over here on these simple agents where there is no real state. They're very fast to set up, but it's hard to extract large amounts of value. Even base Claude Code, you'll see this where the only state that there really is the task list and the context window. But there is no way to easily share state across these various agents and systems to be able to get that real semblance of state without using some external MCP type server, which then adds a lot of overhead. And then we have over here on the other end, which is production agentic systems. And for anyone that's really been building production type agent systems, the biggest time investment that you'll be doing is managing the state, or the fancy word right now is context engineering. So what does the agent get to see at any given time? For example, I have worked on agents that do negotiation calls, and you really want to, throughout that call, know what price are we talking about, who are we talking to, what are we negotiating on. You don't want the agent just to be able to hallucinate and wipe out the state of all the negotiations and change the price. You need to have very tight access controls over read and write access at any given time of the agent for stability and also traceability. And this then leads us to this middle ground where I'm going to introduce something called soft states, which are these semi-structured states that are able to provide 80% of the value with around 20% of the overhead. And the idea behind this is that these local states are something we set up with a folder structure, and we allow Claude Code to then read and write to these state files. You can think of this as almost a semi-structured scratchpad file that it's able to write to. You then say set up a folder structure. Then each agent as it goes maintains a state file, and we just specify that it should be in JSON format and how it should update it and such, and it updates as they work. And then this provides very easy context sharing and context management, because each agent can just read and write to the files that they need to at any given time, and we don't have to configure who's allowed to talk to who. Now, with this being said, there are some very major caveats to this. One is that there is no really way to guarantee the state, and that's why it's called a soft state. You can say, make it this JSON structure, update it this way, but we are not enforcing the updates we would if we were doing a classical agentic system. And secondarily, there is no real access control that you can set up for this. So any agent can look at any other agent state, which could lead to some weird behaviors down the line if you are trying to say, have the agents figure something out. If they can easily access another one's state, they could cheat somehow, but for what we are looking at, this isn't going to be a very big deal. To demonstrate this, I'm going to then show a multi-agent researcher. This is based off of the Anthropic Deep Research blog post they put out, but this will be done within Claude Code in these soft states. First, it will be set up with a custom / command that will initialize the folder directory and then spawn the main research agent. We'll then follow that up where the main research agent goes in to understand the code base, decompose the original query into subqueries, and then spawns a subagent to go and research that query. And then the research subagents will then focus on their research task, compile a result, and report back to the main agent. And finally, that main research agent will write that file to a full report that then has gotten this whole wide breadth of research done in a very short amount of time. Before going into the actual demo, I'm going to take a look here at this Figma diagram that I put together. First, the user's basic research request would come in. So this can be anything about the code base or whatever we are researching. It will then initialize the directory structure, which looks like this. It has a research request folder. It will then make a folder for this session and then set up the general directory structure to then have the system run through that, and then it will call the main agent. The main agent will then initialize its own state. It will do some request analysis. This I have set up to just do a cursory look through the code base to have a general understanding of what it does. And to note here, as it's doing each of these processes, it is updating the main agent state. Each of these subagents will first initialize its own subagent state. It will then do the research process of reading files, taking note of what it's looked at and such, and then write the report into its own state. And this report will contain file understandings, paths that it thinks are useful, and then this is essentially a research summary that then goes back to the main research agent, who will then read all of the subagent states, compile that final report, and then write that back to the session ID directory for then us to read. Or if you are, say, using this, showing the example of exploring an open source package, you can use that as documentation to then provide the AI for implementing something within your project. Before getting into the actual setup of the real code for this, I just want to talk about the use case behind it. The idea behind this is that for a lot of the work that I do, and I know a lot of other engineers do, is working with open source packages. And these packages, especially in the Gen AI space, come and go very quickly, and they change very rapidly. And this then leads to the case where, say, for this structured output or LM integration package Mirroscope, the documentation lag behind because it's being made by a few developers, and the real value is creating a good package and not necessarily keeping the docs up to date, especially as you have your day job and other things you may be doing along the same time. Here, the issue I was running into was how do I use this package to structure function calls or system messages and such with images and text layered together so I have good control over it, but am able to easily switch between different providers. And you can sift through here, you can search for images, things will be out of date, and similar things for if you're using a package, say instructor for your structured outputs. There is so much documentation on this. It could change at a moment's notice. Is it up to date? It might even mislead you because it hasn't been updated in 6 months. And then what you were looking at is no longer what is actually done. And then you end up having to go and look in the package. This idea was to essentially make a researcher that is able to answer these questions for me very quickly and very easily. I can use it for my specific use case, or I can ask it, does this package do the following? It will then go research, and then if it does, it can do it. Let's now take a look at the Mirroscope package itself. First, here's this research command. It will essentially gives it a task, and then it gives it the workflow that it'll go through. So it'll parse the research request, make a concise name for it, make that the session, create the file directory if it doesn't already exist, and then set up the orchestrator state, which then has this JSON structure that I've specified that this is what the state should look like. It will then spawn the research agent, and then it will inform the user that it's what's happening, and some other little things. Then the research orchestrator will then spawn from the command. It will then look at the state. It will then first do a cursory look at the code base. It will then decompose the research query based off its understanding into subqueries. It will log all this into its state. And we are here giving it some very detailed things of how its state works. And then it will work through this workflow to load the context, analyze the requests, spawn the parallel subagents, wait for them all to complete, and then synthesize its findings and put that report in the final report. And similarly in the subagent, it sets up its own state, has its search history, says what files and findings it does, and then it will report back to the subagent. And while this is running, we will then be able to take a look as the files start to show up in the file tree. So we will come over here to research that. I'll put this in that. Live demos, always fun. And there we go. I need to know how to dynamically build prompts with images, text, etc. so I have full control so I can layer the parts of a message as I need. Awesome. So we will hit that off to research and then we will watch this run. And as we can see, it is first going to parse the research request and create the directory. So there we go. It is making the directory now. There we have research request, dynamic prompt building with the date and some things, and then subagents. As we can now see, there is the orchestrator state as it's running, and then the subagents, and it will then soon be spawning the main orchestration agent. Awesome, so there we go. Looks like it is in the initialization state still. Awesome, and there you see, we now have, I need to know how to dynamically build prompts to images and text. Awesome, summarized intent, identified needs, key concepts, and now it is going through and doing this code-based understanding. Fun that a large portion of my job now is just kind of watching these agents run, taking notes, and then figuring out what we need to do. Here, its scope is a unified LLM interface library supporting multiple providers with prompt engineering, structured extraction, and multimodal content support. Awesome. Key components that it probably needs to look at, and then relevant areas, which these are then my file paths to the areas that it needs to take a look at. And now it should be decompose queries, investigate base prompt class, prompt engineering patterns for dynamic construction. Here are the search areas, key terms, designated agents been assigned to. And then we will see here that we have these 5 queries that it's running, and then each of these agents that then it has the link to the state file as well. As you see there, all the state files having gotten created, and then it starts, then each one of these should be running in parallel, so that then we are able to have all this research being done in a very effective way. Since right now we've been sitting here for about 2.5 minutes, and now we have 5 different agents doing deep dives of the code base to then understand how to actually structure the prompts. Instead of us having to read a line of documentation or set this up in a way where, yes, I could have taken all the files, indexed them into a vector database, and then asked questions that way, but that requires some overhead. Similarly, you could have taken all these and put them in, say, a custom GPT and have that be the files it searches over. That, though, is the stateless approach, where it will work and it will get you there some level, but it does not give you the level of granularity and really deep understanding that you would get with something like this, and it requires some level of overhead. Where this, you drop these in, run Claude research on the command, and it will come back with a documentation file that is specific for your needs. Here we will see as each of these is going. I don't think any of them have updated their states yet, but we will see here that the current phase is synthesis, so it's synthesizing the findings. I wish you could expand this tool use because it says 35 more tools. Another video will be setting up some tracing on this so that we can easily see which agent has run what with some hooks, but that will be for another day. And while we're going through this, looks like the final report is done, but I want to point out the idea here is that this is, I would call it semi-structured, because it is not guaranteed to actually update the states properly. Say here, would it change relevant areas? Possibly. There's no control over what it does. The agent will do what it wants to do. And here, while it made each of these agent states, these subagents do not appear to really have updated them whatsoever, which that's a little minor problem there, but this is where we don't have that full understanding of the states or of the context and deep control. But we then get back this full report, which then tells us here is how within Mirroscope to layer these messages in a way that offers that very different way or very tight control over how to structure the messages. Detailed findings, here are the files we need to look at, here's how it will all work. Dynamic message composition, and then here are all the files if we want to take a deeper look at what we want to look at. And all this is amazing because this is then able to make customized documentation for yourself, for your specific needs, that then you can feed into your AI agent or have yourself do it. And the idea here, though, is that we were able to get all this done by giving the agent these workflows and states that it can write to so that it has a very clear understanding of what it needs to get done. And coming back after that demo, the real question becomes, what does this mean for us as the engineers? And first thing now, with these soft states is, right now we have to explicitly prompt how these states are created and managed. But what we are seeing here, though, is that the agents will eventually be able to write these states and come up with them on their own. As you spawn, it will understand how it needs to structure itself and its interactions to keep going. Where then we can see here that these soft states will eventually become production infrastructure as these models get exponentially better. And by then, the models are improved, and we won't need to really worry about maintaining the access controls ourselves. The agent will be able to write them and set them up in a way that works best for it. It will be able to maintain the state in a way that it understands. And we don't have to, maintain it or instruct it the way that we are currently doing now. And the idea here is that from an engineer, we are evolving to a guiding force of these agents. We are just not even orchestrating, but just pushing and nudging the models in the way that we want them to go. And think of yourself as a guide and not an engineer of these agents. It's like you shape how these agents will learn from yourself and then how they will architect themselves and build out. And you just give them more of a task and a general idea of how they should work, and then they can go and figure it out. And while I would not recommend this for production systems, this is very powerful for building out local workflows for yourself that are then able to accomplish large amounts of work at once just by running a custom / command on whatever you're doing. Thank you everyone for the time, and I have here some different QR codes to connect. I'd love to hear if anyone has implemented these states and how it worked out for them. You can find me on my website, X, LinkedIn, probably somewhere else if you can figure it out. But thank you everyone, and see you guys in the next one.